Welcome to the Transom Podcast, a monthly roundup of the new features on the transom.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 51 for February 2019. And you can find a transcript of this podcast at transom.org/newsletter. Ladies and gentlemen, I present this month's puzzle. Here we go. Think of all the ways of arranging the digits 1 to 9 to make a 9-digit number. How many of these 9-digit numbers are prime? And it's not as difficult as you may think. That's your puzzle for the month. The answer will be at the end of this podcast. And while you're thinking about it, I'll run through the most notable new additions to the Transom website during this last month. Okay, first of all, pick the primes. It's an addictive challenge to quickly distinguish between prime and composite numbers. The activity encourages you to improve on your personal best time for each of the different levels, and the levels contain numbers increasingly large. It's a great fun idea for the last 10 minutes of your maths lesson, and you might want to have a go at it yourself before unleashing it on your pupils. It's great fun. Another new activity added to the Transom website this last month is called linear programming, and it's now ready online for pupils to use to practice forming inequalities from real-life situations. So even if linear programming as such is not part of your syllabus, inequalities could well be. So this activity just gives a different slant on the idea, lets the pupils see what the graphs of the inequalities would look like, and it makes use of the Desmos graph plotting program to produce the colourful shaded regions. So there are 5 levels, plus a link to some exam-style questions if that's of interest for you. Factor tree puzzles have been added to the very popular Factor Trees interactive exercise. I suppose it is the way the trees grow according to the factors entered that makes this exercise so much better than the equivalent exercise from a textbook. If you haven't yet done it, have a go at the factor trees, and you'll see what I mean about the tree growing as you enter the numbers. But the additional puzzles that have been added are fun to do too. Snappy sorting will give pupils some idea of how the algorithms used by modern computer technology, search engines, online shopping, all those sort of things, how they actually sort data. So pupils could learn about the bubble sort and actually sort the numbers into order, but is that the fastest method? Over 2/3 of the people who visited this activity already have gone on to claim a trophy for completing it. I can see from the logs on the server. So this activity has become quite popular already. It's called Snappy Sorting, and remember the links to all of these things are at transom.org/newsletter. Missing lengths. It's not a new activity, but it has been expanded. And the questions have now been arranged into more levels in a more logical order. So there are 4 levels plus a link to exam-style questions. Wow, there was a lot added last month, wasn't there? I'm still going here. Algebraic perimeters. It's brand new. It's because I kept seeing these questions on past GCSE question papers. Where a shape is drawn and the lengths of the sides of the shape are given as algebraic expressions, and pupils are asked to do some calculation involving the perimeter and finding the unknown letter and so on. So it's now an activity on Transom, so you can have a practice at lots of these questions, And again, it links to some exam-style questions at the end. Estimating correlation is not something that everybody needs to be skilled at, but it was written specifically as a reminder for some of my older pupils who were learning about scattergraphs and correlation. And so it's a very quick activity. It doesn't take long, but it's just a little challenge to see if you can estimate what the correlation is for some thumbnail images of scattergraphs. Surface area has just been expanded. That could be a joke there somewhere. It's more of a traditional 4-level exercise, beginning with a face counting level. That's level 1, leading on to some more tricky puzzles in level 4. Okay, this month ahead, February, is known for Valentine's Day, which falls on the 14th. So if you want to prove that you're a real trendy teacher, although to be trendy you probably wouldn't want to use that word trendy, maybe a cool, sick teacher, maybe, something like that, you could surprise your pupils with one of 2 Valentine-themed starters on the 14th of February. So one's called Valentine's Puzzle and the other is called Love Maths. Again, links are in the newsletter. Now, there are 2 vocabulary activities on Transom, Shark's Dinner and Code Cracker, and both involve suggesting letters that may be in hidden words, just like in the classic Hangman game. I've always started, when I've been doing these activities, by guessing the letter E, then T, then A, as these are the most common letters in English. But I learnt from a podcast that 3-letter words do not have the same expected letter probabilities as 4-letter words, which I hadn't realised. Here, have a listen.
So that was really well done. So you just proved that from the guesser's perspective, you had a strategy that happened to work beautifully there. Could I learn that strategy as well pretty quickly?
Quite boringly, there's a table in my book which got the first letter on the board. The strategy for this, I should say, I spoke to Nick Berry, who's a data scientist at Facebook who looks into these things in the spare time. And what he said to me was, Tom, I bet you think you're good at Hangman. You're not. And then he said, people who think they're good at Hangman, the more naive ones, what they guess first is the vowels, which is indeed what I used to do. So I was at the lowest level of sophistication on his strategy. And then he said, if you get a bit more sophisticated, you learn about letter frequency analysis. It actually started in Baghdad in the 9th century. There was a guy who went through the Quran and wrote down, a guy called Al-Kindi, he wrote down the frequency that every single letter popped up. And he didn't just do this for fun. He did it because cryptography at the time was almost always based on letter substitution. So, for instance, you'd change the word cat you'd add 1 to each letter. So you'd change the word cat to DBU, and then you'd send your letter. And he realised that if he knew that a particular letter popped up more and he had a big enough corpus of data to decode, he could begin to work out which letters were which. So he blew apart cryptography by doing this. So from that, we have the basic letter frequency in the English language. And he said, well, I bet you think this makes you sophisticated. And then he said, well, actually, it's not. Because if you think about it, in Hangman, what you've got is a lot of words you'd never use. A lot of the most common words. You'd never use the word a in Hangman. You'd never use the word and or of or the. I mean, if you play Hangman with someone who puts down the word the, then that really is the time to reconsider your friendships. And so then he produced a different letter frequency of the words in the English language, excluding those. So previously it was ETAOIN. And if you get rid of those words, you're left with ES for sugar, IARN.
So that's the optimal kind of first guessing streak, yes?
No, because then he said, you've forgotten about the amount of information you've been given. I've just been told that this is a 4-letter word. Well, the frequency of letters in four-letter words is completely different. Think about it. Think of all the endings that you can't have. You can't have the ing ending. You can't have the tion ending. It would be mad if the letter frequency in four-letter words is the same as the letter frequency in the English language. So actually, the most common letter in four-letter words is A, but the most common letter in five-letter words is S. It's E in six-letter words, and it's I in 13-letter words.
Once you land the first letter, then you reassess the kind of word that you're thinking about, or no?
Well, yeah, so his whole principle behind this, which I certainly subscribe to, is the really key thing is to get that first letter. And so if you've, let's say, as was the case for this, it's a four-letter word, and I've guessed A because that's the most common letter in four-letter words. Well, if that doesn't come up, you've just changed the search space again. The frequency of letters in four-letter words that don't include the letter A is completely different. So that's your attack strategy for getting the first letter. And then, obviously, you could extend this if you had a lot of time on your hands, but then I just went back to the letter frequency in the English language. Then I went to the letter frequency for silly and just decided to go J. So I went a bit off-piste there.
All right, that was very stressful, though. That was fun. Can we play another?
I'm sweating. Yeah.
That was an excerpt from Freakonomics podcast, episode number 247, in which Tom Whipple, who has consulted an army of preposterously overqualified experts to find the secret to winning any game, and he was talking about letter frequency. So maybe now you should try Shark's Dinner and Code Cracker to see if you are any better. And talking of podcasts, another one I listen to is from one of my favourite comedians, Frank Skinner. And my ears prick up when people talk about things that I've sort of taken an interest in. In the British Museum, there is the oldest board game that has been found, and it's called The Royal Game of Ur. Ur is spelled just U-R. So I made the transom version of this called Remainder Race, and it's based on the same style board, with the counters are moving around the board and the same sort of rules, but the moves are determined by the remainders when the square on the board number is divided by the dice number, if you see what I mean. Anyway, so when anybody talks nowadays about the royal game of Ur, my ears prick up, and, well, here it is, Frank Skinner.
We saw do you know the royal game of Ur?
No?
That's the thing at the British Museum, long fascinating, called the Royal Game of Ur, which I always thought was named by an overzealous stenographer. So I'm like, this is the Royal Game of, and he's just written it down. It's that's also like a game from about 5,000 years ago, like a sort of like dominoes cum Ludo. Let's go to the British Museum.
Well, I find
Brilliant.
Some of the old school games, though, they're quite basic, aren't they, some of them? I mean, there's no Miss Scarlet or Prof Plum.
Well, this one looks hard, though.
Does it?
The Royal Game of it looks really hard. It does. I mean, I think they've worked out you can buy them there to go home and play with.
Really?
Anyone fancy a game of the Royal Game of? Oh, what a great Christmas that would have been.
You are listening to the Transom podcast. You can find Transom Mathematics at www.transom.org.
For future reference, there are 2 mirror sites that contain all the Transom starters and activities. They are at transom.com and transom.info. The only difference is all the big database containing all the subscribers' details isn't shared with those sites, so you won't be able to log in there. But if transom.org does go down, I will then transfer the database across so that you'll be able to log in there. I just thought I'd mention that so that your lesson doesn't get disrupted if there is a break in communication and transom.org goes down for some reason. Anyway, thank you so much for your feedback, comments and suggestions. In fact, if it wasn't for the messages I get from people using Transom, I might start to feel quite lonely, because in this office here, the old joke, of course, is how many people work at Transom? And the answer is about half of them. Ha! Well, actually that joke has got no foundation at all, because there's only one person working at Transom, that's me. So I do appreciate to get any feedback, whatever, positive or even the odd but quite rare typo or mistake that people find. Please let me know, and then I usually correct it straight away so that everybody else doesn't have to put up with it. So keep the feedback coming. I really appreciate it. Thank you. Okay, the solution to this month's puzzle is none. None of the 9-digit numbers are prime because all of them will be divisible by 3. So this might be a good time to look at the divisibility tests to remind yourself that if the sum of the digits in a number is divisible by 3, then the number itself is also divisible by 3. And adding the digits 1 to 9 gives a digit sum of 45, which of course is 15 times 3. So any number that you make from the digits 1 to 9 will be a composite number, not a prime number. That's all for now. Have a good February. See you next time. Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.